Electricity and magnetism, two of the most important physical phenomena existing in our world, and they're fundamentally linked by a concept known as special relativity. So the idea behind electricity is that charged particles interact with each other through electric fields. Protons and electrons both set up radially symmetric electric fields, and these fields exert forces on other charged objects. The arrows drawn here are called field lines, and they point towards the direction positive charges would accelerate due to the electric field. Not only do charges produce electric fields, but moving charges also produce magnetic fields. Depicted here is a wire with electrons flowing leftward, creating a current. This current produces a magnetic field centered around the wire and extending radially outward. Unlike an electric field, however, this magnetic field only affects charges that are moving. But here's the interesting part. Whether an object is moving or not depends on the reference frame you view it from. In simple terms, your reference frame is defined by your position and your velocity. For example, if I throw this frisbee here, I could measure its velocity, but the measurements I'd make would be specific to my current reference frame, which is at rest. If instead I chased after the frisbee and measured its velocity while running, I would record a different measurement than if I was standing still. The takeaway from this is that measurements of velocity are reference frame dependent. And special relativity further states that different frames of reference also lead to different measurements of length. Let's return to our current carrying wire. Suppose that we place an electron near the wire. The electron experiences neither a magnetic nor electric force, so it remains at rest. But if we chose a reference frame moving along with the electrons in the wire, then we'd actually measure the electrons in the wire to be at rest, while the protons in the wire and the electron we placed near the wire are now moving to the right. This means that the electron is accelerated away from the wire by the magnetic field produced by the protons. But one fundamental property of reference frames moving at constant velocities is that they must agree on measurements of acceleration. So what's actually happening here? Well, it turns out in our new reference frame, we measure the positively charged regions in the wire to be longer than the negatively charged ones. This means that the wire now has a net positive charge, which attracts the electron and perfectly cancels the magnetic force. So all it takes to go from electricity to magnetism is a shift in perspective.